Hello and welcome to my video on power for Physics 20. So power is measured in a unit called watts, and you've probably heard of watts before because they'll talk about power bricks or wall warts, which are used to charge your phone or your laptop, and those will have a certain number of watts that they are able to pull from the wall. USB used to be like 0.5 watts, 0.5 amps, and then if you multiply amps and volts, it gives you watts. Anyways, now we're talking about like 5-watt charging or 10-watt charging for phones. It's getting to be a little bit ridiculous. By the time you're watching the video, probably 50-watt charging for a phone over USB-C. It's getting pretty crazy. So anyways, it's measured in watts, okay? And we know that power is work over time, okay? Which before in the last video we talked about all the things that work can equal. So really power can equal all of these different versions here. Okay, so if we think about power as watts, and we know work is in joules, okay, joules over time, which is in seconds. Okay, and if we remember that joules were kilogram meters squared per second squared, and now we have it over seconds, we could also call this kilogram meters squared per second cubed. That is a watt. Kind of interesting. All right, and what else we could say is that if we talk about work versus time as a graph, right? Then you could take the slope of that graph, okay? Because slope is rise over run. So in this case, the slope of the graph would be rise over run, which would be work over time, and therefore the slope is power. So interesting to note, the slope of a work versus time graph is power. Okay, so kind of similar to how the slope of a distance versus time graph is velocity, right? It's the same sort of conversion. If it's over time, then it'll do that sort of thing where the slope is an important value. Oftentimes, most of the time. All right. So, yeah, so those are the units. I already talked about that. So it's an interesting process to look at the units, which we just did. It's also really important to note that you can have multiple versions of the power formula. I think only one of them is given in your formula sheet. I honestly can't remember which, but it is the change of energy over time. It's the work over time, or the force times distance over time as well. All right, let's take a look here at a few example questions. So to avoid getting hot grease on the floor, you take 2.2 seconds to lift a 1.1 kilogram load of fries vertically into a bin 45 centimeters from the deep fryer. Calculate your power output while doing this. So you're doing this really quickly because you don't want to drip hot grease on the floor. That's the basic premise. So if we think about it this way, power equals work over time, or another way to see this is force times distance over time. Okay, but what is the force required? Well, in this case, it's mass times gravity, right? That's ma, and you're fighting against the mass of the load of fries, so ma, and then distance is the height that we've lifted, so mgh. Ooh, you maybe remember mgh from last year. If not, it'll be in the next couple of videos. But mgh over t. All right, so this is force times distance over time. Okay, so let's go ahead and write those down. So the mass is 1.1 kilograms. Gravity is 9.81 meters per second squared. The height is 45 centimeters, so 0.45 meters. Careful that you're always in SI units. This is very, very important. And then over time, well, it took 2.2 seconds to do this. So I'm just plugging this into my calculator. And assuming I did it right, 2.20725 watts. So 2 sig digs, so 2.2 watts of power during this lifting process. That's pretty good. Pretty good. Lots of power going on. All right, let's take a look at this next one here. I always recommend pausing the video, trying out yourself, and seeing if you can do these questions. But I'm going to go ahead and try this out now. An electric motor powers a conveyor belt used to move boxes across a warehouse. The motor produces 750 newtons of force and moves the belt at a constant rate of 1.75 meters per second. Calculate the power output of the motor. Well, power equals force times distance over time. Well, I just want to point something out to you guys. This is force times distance over time. What is distance over time? Velocity. So force times velocity is our power. So notice here that we can actually go 750 newtons. And then we can say 1.75 meters per second. And we can straight up multiply these two together. So 750 times 1.75. And we get 1,312.5 watts. And there's 3 sig digs, 1.31 times 10 to the 3 watts, or 1.31 kilowatts. Either one of these two would work perfectly. And that's actually quite reasonable. A normal 15 amp breaker is 1800 watts or something like that. So a normal outlet, the maximum a normal outlet in your house could do is about 1.8 kilowatts. So this is quite reasonable in terms of value. All right. I hope this video helps you better understand the power topic from Physics 20. And good luck, and see you in the next video.